is Sid Parker, and I'm in the Chem Lab 120 here. And today I'm going to be talking about what's in the water. Water is an important resource, so you kind of want to know if it's safe for you to drink. Will it poison you? Will you die upon consumption? How can you tell? So we used two different tools of the trade, which was the IR spectroscopy, which uses the absorption of a photon through infrared waves to determine the kinds of hydrogen bonds the substance in question has. So it basically tells what kind of functional groups your substance has. And to prep for an IR spectroscopy, we took our sample and we plopped it between two glass slides with a drop of potassium bromide between them. The other tool of the trade is the NMR spectroscopy, which uses radio waves to excite hydrogen protons, and it determines the peaks and ratios of the different hydrogens for our unknown substance. And to prep for this, we dissolved it in chloroform. So I have three different unknowns. I have unknown 19, 19.1, and 19.2. And so I'm going to show you exactly how to tell what sort of molecule matches up with what we have in our unknown substance. So here is a list of the possible candidates that we have. This is an IR reading. It shows the different functional groups of all of these substances here along the side. And here's an NMR, which shows the ratio of the areas as well as the peaks for our possible candidates. So for our unknown 19, if you want to look here, you can see how it forms a lot of points. You want to look for the deepest point here, which is 3035.16, which falls quite nicely right here, showing that it is a carbon to hydrogen benzene ring. So again, looking back at our possible candidates, we have three that have a carbon to hydrogen benzene ring here. So to whittle it down even more, we're going to go ahead and take a look at an NMR reading of it, NMR spectra of it, which shows that it has one peak here, and it has a ratio of just 1. And of our possible candidates, looking at the NMR, really only benzene has the 1 peak in the 1 ratio. So we're going to go ahead and take a look at our second unknown, which is our unknown 19.1. And again, we're just going to take a look at the bottom peaks here. You can see that the first one right here lines 3,368.58, which falls in between the oxygen to hydrogen bond. And the second one, 2,973, falls in between the carbon to hydrogen single bond functional group. And of those, only 3, the methanol, ethanol, and 2-butanol, both have the oxygen to hydrogen and the carbon to hydrogen single bond. So again, we're going to go ahead and take a NMR spectra of our unknown substance, which, as you can see, has 2 peaks and a 1:9 ratio. And again, looking at our possible candidates, only one of them has a 9:1 ratio. So we can tell that this substance is 2-butanol. And just to finish things up, we're looking at our last unknown substance, 19.2. Again, we're going to look at the deepest peaks, which show that we have a carbon to bromine functional group and another carbon to hydrogen single bonded functional group. And there's only really one of them that has a carbon to bromine functional group here, but again, we're just going to go ahead and look at the NMR spectra just to double check. And as you can see, 2 peaks with a 1:3 ratio. So you can tell that this substance is 1,2-dibromo-2-methanolpropane. Just a quick recap, 19 shows that it is a benzene, 19.1 shows that it is 2-butanol, and 19.2 shows that it is 1,2-dibromo-2-methanolpropane. So what exactly does this mean for us? Now that we've figured out what exactly our unknowns are, we can sort of tell how they will affect us. Benzene, not great. It's fatal in large doses if consumed orally. It can cause vomit, irritation of the stomach, dizziness, sleepiness, convulsions, rapid heart rate, and coma. as told by the Agency of Toxic Substances and Disease. So, and the environmental risks of benzene, it can react with other elements to produce smog, it's hazardous to aquatic life, and it slows down plant growth, as told by National Pollutant Inventory. Our two other unknowns are described basically as just mild irritants by PubChem, but it's better safe than sorry. Not something you would exactly want to consume either. So just to conclude, with the assistance of NMR and IR spectrometers, we can tell that our substances aren't safe for human consumption. And here are my references. Thank you for your time.